let's discuss on the total differential. So if z is the dependent variable of various independent variables ranging from u, vw down to any number, then the total differential dz is given by the sum of the separate partial differentials of z. Therefore, dz is equals to partial derivative of z with respect to u multiplied by du plus partial derivative of z with respect to v multiplied by dv plus partial derivative of z with respect to w multiplied by dw, and it continues. Now let's take a look at this example. It says if z is a function of two variables x and y, and z is given by this equation of x squared y cubed plus 2x minus divided by y plus y plus 1, determine the total differential. Now if z is given by two variables, then the total differential formula, that is dz, will be equals to dz over dx multiplied by dx plus dz over dy multiplied by dy. So all things being equal, all we just have to evaluate is dz dx and dz dy, and then we will substitute into the equation. So let's recall ourselves what z is. Z is x squared y cubed plus 2x over y plus 1. And we are asked to evaluate dz dx. And when we are evaluating partially with respect to x, our y is kept constant. Therefore, we have y cubed with full multiplied by the full differentiation of x squared plus 1 over y multiplied by the full differentiation of 2x and plus the full differentiation of 1. And in essence, we have this to be y cubed multiplied by 2x plus 1 over y multiplied by 2 plus 0. And this will give us 2xy cubed plus 2 over y. Likewise, we have for dx, dz, dy. And for dz, dy, we are putting x to be constant. Okay, we are keeping x to be constant while differentiating that. So we have x squared multiplied by the full differentiation with respect to y of y cubed plus 2x multiplied by the full differentiation of 1 over y plus dy of 1. So differentiating this, we have x squared divided by 3 multiplied by 3y squared plus 2x. Now 1 over y is the same thing as minus y raised to power minus 1. And differentiating this, differentiating y raised to power minus 1, we have minus y raised to power minus 2. And this can be written as minus 1 over y raised to power 2 according to the law of indices. So this is minus 1 y raised to power minus 2. And then simplifying, we have 3x squared y squared minus 2x over y squared. So let's recall the formula of our total differential. That dz is equal to dz dx multiplied by dx plus dz dy multiplied by dy. Now let's substitute our dz dx. which is this. That will give us 2xy cube plus 2 over y multiplied by the x plus our dz dy, which is this. 3x squared y squared minus 2x over y squared multiplied by dy. So here is our final answer for the total differential of this. Let's take another example. Number 2. It says if z is a function of u, v, and w, and z is equal to 3u squared minus 2v plus 4w plus 4w cubed v squared. Find the total differential dz. Now the first thing to do is to write out the formula for the total differential. We know that the total differential, given that we have 3 variables, will be dz du multiplied by du plus partial derivative of z with respect to v multiplied by dv plus partial derivative of z with respect to w multiplied by dw. So all we are going to be looking for is dz du, dz dv, and dz dw. So let's begin with dz du. That means we are going to differentiating du of 3u squared minus 2v plus 4w cubed v squared. Now, while differentiating with partially respect to u, the other variables are being kept constant, and that means both v and w are kept constant. Okay, so let's split this further for more understanding. And we have this du squared minus d du of 2v plus d du of 4w cubed v squared. So with this done, bring out the constant out and leave the full differentials, and the constant in this term is 2v multiplied by the full differential of d du of 1. The constant in this term is 4w cubed v squared, because why? Because these are 3 variables, and when we are differentiating partially with respect to 1, the other 2 are kept constant. And d du of 1. Now this will give us 3 into 2u minus 2v into 0 plus 4w cubed v squared into 0. Nullifies to 0, nullifies also to 0. And our answer here will be 6u. The same thing is done for dz dv. Now for dz dv, we are differentiating partially with respect to v of 3u squared minus 2v plus 4w cubed v squared. And let's split further. And then we have 3u squared minus partial derivative of 2v plus partial derivative with respect to v of 4w cubed v squared. Now let's separate terms, bringing out the constants. 3u squared is a constant. Full differential with respect to v multiplied by 1. 2 is a constant multiplied by the full differential with respect to v of v. And 4w cubed is a constant multiplied by the full differential of v squared. And this will give you 3u squared multiplied by 0 minus 2 multiplied by 1 plus 4w cubed multiplied by 2v. And our answer will be minus 2, because this nullifies to give 0, plus 8w cubed v. And finally, you can pause the video now and try for dz dw. And dz dw is d dw of 3u squared minus 2v plus 4 omega w plus 4w is power 3 v squared. And then when we differentiate partially with respect to w, we can realize that our term will be left with 0, 0, and plus 12w square v squared. And our answer will be 12w squared v squared, because u and v are kept constant. So let's go back to our formula for the total differential of dz. We recall that it is this. dz is equals to partial derivative of z with respect to u of the u plus partial derivative of z with respect to v of the v plus partial derivative of z with respect to w of dw. And then we make our substitutions. dz dv du is 6, and that is 6u du. dz dv is minus 2 plus 8w cubed v multiplied by dv, and dz dw is 12w squared v squared multiplied by